this is a one side, but actually less than 0. But how to calculate it is exactly the same, right? Only difference is just a minus. You have a minus number for the z value. I mean, the critical t will be the negative number. And then if your number, our t value is smaller than that t, then we can talk about it. When should I use the smaller than, or when should I use the larger than? If you have a beta head is a positive, then you can use a one side, the greater than 0, or you can use a less than 0, negative, when the beta head is negative number. Okay, so that's why this is another example. The data file name is MEAP93. So trying to find out the passing math test, percentage of students who passed the math test. We're trying to do this for all the positive. This is positive, positive, positive. Now this is negative. That's why we choose this one. And then trying to do the t statistics that our null hypothesis is the enrollment. Enrollment will not affect any percentage of students passing math test. 0 means it doesn't have any effect. But we got some number. Yeah, even though this is quite small, but again, it can have a clearly, obviously small effect, right? So we cannot judge it by the size of this number. Or we can say, yeah, obviously this beta is smaller than 0. And then we calculated our t statistics for the enrollment, and then you can find the t value for our case. And then you calculate the degree of freedom here the same way, because we estimate 1, 2, 3, 4. So right, this is 1, 2, 3, 4 numbers. We estimate 4 numbers, so you have to take it out 4. Together this is 4, right? Minus 4. So you can calculate the degree of freedom here, and then using the degree of freedom, yeah, you look up the table, again the table, and you can find out the critical value. But as you can see, my critical value, again, if we take a look at it, minus here, this is the minus 1.65. This is 5%. However, minus 0.91 locate here, right? Which means even though null hypothesis is true, still we can get our current result with a higher than 5% probability, right? So that's why we cannot reject our null hypothesis, right? So we cannot reject the null hypothesis that there is no effect. So null hypothesis means there is no effect, but we cannot reject the statement there is no effect. So that does not prove there is no effect, right? But we cannot say the null hypothesis there is no effect is false. Maybe it's false, maybe it's true, but I cannot tell. Okay, that's a hypothesis testing. Hypothesis testing doesn't disprove the null hypothesis, but in this case, maybe there is an effect on the enrollment, but I cannot tell null hypothesis is not true. I cannot tell that. Okay, so if you just take a look at it, this one is we use a log form, right? Here we didn't use any log form here. If we use the total teachers conventions, the step, enrollment, and so on. But here we apply the log here, log and log and log here. So now we have all different numbers here. And you can see the R square is slightly higher. Now we can talk about, again, this is the only minus, we can talk about this one. So we can set the null hypothesis is still enrollment doesn't have any effect. Since this is negative, that's why we said, okay, it has a negative effect. And then you find the t-statistics. Again, what we talk about is our big topic is a linear regression, right? So why we call this linear? Because even though log is not linear, we treat mathematically we treat this log enrollment as a new factor. Okay, so the calculation, how to calculate the t-value for the log, is exactly the same. You just treat the log enrollment as a new factor, and then you calculate the beta j over standard error of the beta j hat, and you calculate, you got a minus 1.87, but 5% the critical value is a minus 1.65. So if you draw the graph here, again, minus 1.65, this is 5%, but minus 1.87 located here, right? So the probability to getting our result, if null hypothesis is true, will be the smaller than 5%. So that's small enough so that we can say, right? So hypothesis can be rejected. We can reject because we can say the effect of the log in row has a statistically significant effect on the percentage of the student who passed the math test. Okay. So same meaning. So what is a minus 1.29? Minus 1.29 is this minus 1.29, right? So that's the how much the log in row change increased by 1. How much the math percentage increased. So log enrollment is the actually this is like similar to the derivative. So you can find out this difference of enrollment divided by the enrollment, and right. So actually, yeah. Then you can talk about it. You can think about what is the changing enrollment changing by 1%. So log change by 1 is like a 1% change, and then how much it percentage of the student increase or decrease. Actually, it's decreasing, right? It's minus. Two-tailed test is we are not talking about this plus or minus. We just simply say it's not 0. So absolute value, it said, even though it said absolute value, but so we are not thinking about it on the positive side or negative side. We just talk about it's 0 or not. In that case, we have to separate out 5% confidence interval will be split out here. So it's 2.5% here and 2.5% here. That's why the critical T will be a little bit different. Okay, this is the college GPA data, and we do the regression and we find out which one we're gonna look at. So we can calculate all the t value. So high school GPA versus ACT score, and is it lectures missed per week, how many lectures the student missed per week, and we can estimate what will be the college GPA. We can calculate the t again. It's all same. So what will be the 4.38 will be 0.412 divided by 0.094. And this is greater than our critical t. Critical t is 2.58, so it's greater. So we can say we can reject null hypothesis, which means high school GPA has a clear effect on our college GPA. And this one is smaller, right? So that's why maybe ACT score, it may have an effect, but we cannot say, we cannot reject the null hypothesis. What is a null hypothesis? Null hypothesis means ACT doesn't have any effect on the college GPA. We cannot reject that statement. Okay, here is also why it's absolute value here is actually the critical T on the other side, which is actually this is why this is happening is this is a 0, and then if you have a like exactly same, it's a 0.025, 0.025, right? And this value is t, then this is minus t, so it's exactly the symmetric both sides. That's why we just compare. If this is minus 3, if this is a 2.58, the critical t, and this will be minus 2.58. And my number is a minus 3.19, which means it's located here. So clearly, what we can tell is there is a very small probability that we can get our result if null hypothesis is true. So what you can say, and this is a significant, this is significant, and ACT doesn't have a significant here. So effect of the high school GPA and skipped are significantly different from the 0, so that means there is a clear effect. However, the effect of the ACT is not significantly different from 0. Maybe it's different, but according to our result, it may not. We cannot reject the null hypothesis. Statistically significant means is the regression coefficient is different from 0 in the two-side test. The corresponding value is said to be the statistically significant. So again, this is a two-side test, right? Because it doesn't, I don't care it's a positive effect or a negative effect. We can just say it's a statistically significant, which means it's not 0, which means there is an effect. If the number of degree of freedom is large enough means it's actually if you use like a really big, large enough, this t becomes to the z. Okay, so I can go back to the. As you can see here, the number is getting slightly smaller, but final number is like a z. So z value is when the degree of freedom is greater than 1000 or really large, then we can assume that's a z value. So t is actually, when we use a t instead of z, so t replace z when we don't know the unknown sigma. So when we don't know the sigma, we cannot use a z. So, but we can estimate our sample standard deviation, right? So using sample standard deviation, we have to calculate our value z. But since this is not available, we have to use something like this, and s. And this will be the t. We slightly modify the number t. The reason is our standard deviation can be wrong, and then we have a very small number of sample. So we just modify the t, the value. We have to use a z as a t instead of t. So when the number of sample is getting bigger and bigger, which means the degree of freedom is getting bigger and bigger, that is getting close to the z value. So theoretically, infinity number of degree of freedom, t value is the same as z value.